Good afternoon, scholars. Today we're going to be talking about a subject related to 3D figures called cross-sections. Cross-sections, what we're essentially going to be doing is studying the different parts or layers that make up a three-dimensional object. The first term that we're going to start with, at least in terms of our definitions, is going to be cross-section. Cross-section is a 2D shape. It is the physical slice or the intersection that we would say a plane makes with a solid. If you remember back to the beginning of the year, a plane is that two-dimensional figure. It's essentially like the length and width or the x and y coordinates spreading out in terms into infinity. Often we saw it drawn as like a rectangle intersecting something like a line. Today we're going to talk about how a plane can represent a portion of a 3D object. So for instance, let's take a look at an orange. Orange, if we look at it just as a normal three-dimensional figure, as we saw last week, is a sphere or a ball. But what happens when we divide this orange into pieces? Let's take a look. Got a knife, got our orange. We're going to go over here and cut it. So there's different ways that we can talk about the plane intersection itself. We have terms like vertical and horizontal, which we're going to go over again. But for right now, what I'm going to do for this orange is I'm going to do a vertical slice. I'm going to take my knife, cut it from the top, and go down. So from the top down is going to be our vertical slice. I'm going to start here and slice through. Our plane essentially is our knife, and now we have what's called a cross-section. This juicy orange. And remember back here's a navel orange, so we don't have any seeds. But the cross-section or the two-dimensional shape, this top layer right here, is going to just be a circle. So we're looking at just a plain old circle. If we now take this once again, and we're looking at our plane figure, if we do a horizontal slice, like we're cutting from the left to a right, or we're following, say, something like our XY plane, that piece that we cut off is just going to produce another circle, essentially. However, if we take another slice and we go from our vertical this time down, we end up with a different type of cross-section. So the way in which we do our cross-sections, or these planal intersections through our three-dimensional figures, are going to generate different types of shapes in a way. Like for instance, if we take a soda can, or we take this coffee cup, and we cut it across in a horizontal fashion, we'll have another circle. But if we cut it vertically, we're going to end up with, say, like a kind of like a U shape, the middle, the portions that join around. What I'd like to do now is show you another example in terms of how this gets played out in the real world. Next up here, we have a video by the YouTube account StoneFX83, where they're printing a Millennium Falcon. We can see from the video how we have to take and consider this notion of cross-sections as a 3D printer goes about its business on the two-dimensional plane. The layers and layers and layers that it stacks up horizontally, or that accumulate in the vertical sense, eventually produce this 3D object. Just like our orange slices and how we can cut our orange into infinite bit of pieces and stack them on top of each other, here a 3D printer essentially uses its reservoir tip along with its other various materials to produce a 3D plastic model. And that, ladies and gentlemen, is how a 3D printer prints.
Now we're going to take a look at the website GeoGebra. It's a fantastic website where you can go and look at various 3D models and two-dimensional models under this guise of understanding interactively with geometry. In this particular diagram, we have an interactive 3-dimensional rectangular prism. We know it's a rectangular prism with a rectangle on the top and matched on the bottom in parallel and congruent sides. In addition to that, we also know it's a prism because all the sides going around it are going to be parallelograms. If we remember through our definition of parallelogram, we're talking about opposite sides which are congruent, paired up here, and opposite sides which are also parallel as well too. For this particular image, our blue rectangle is going to represent our slice to the orange, or what we would call our cross section. Cross section of this particular figure is going to be rectangular. If we begin to move this plane as opposed to from its horizontal position, and we begin to change it to a vertical position, we can see, at least in this particular prism, how it's getting stretched out. But given the particular shape, we know that it's going to continue to be rectangular in size. We can also move where exactly the plane is being rotated from as well too, and little objects we can play around with. Can also rotate them and generate different shapes too, like slightly trapezoidal and such. Next up, we're going to take a look here. It is going to be with a triangular prism. Prism definition, once again, that those matching paired planes on the top and bottom, parallelograms connecting the two sides. Here, our plane shape is going to be triangular. As we rotate it, begin to stretch it out. And what's kind of cool with this particular shape is that if we have a completely vertical plane, we end up with a rectangular shape. Is the top portions of our prism box we can connect with not triangular pieces, but rectangular. So one thing to take in consideration when we're talking about cross sections is going to be the direction that you'll see. Typically, when you're reading something, or if you're like an engineer, for instance, you're using terms like vertical and horizontal because you're taking in consideration proximity to the ground. Here again, we have now a rectangular prism, rectangle on the bottom, or what could be kind of close to a square almost. If we're taking our plane, we begin to rotate it from the horizontal to the vertical, stretches from a rectangle to a trapezoid, and eventually, when it meets at the top, it's triangular. We have a triangular bottom base. This one here, as we rotate it, maxing out the sides, it continues to have that triangular shape until we oververt it and we can create a slight trapezoid. So it's all dependent upon where exactly you're rotating from. Are you directly in the center, concurrent, concentral, and the like. Next up here we have a cylinder. Just like similar to our orange, our cross section is going to be circular. But what do you think happens when we rotate our plane from the horizontal to the vertical? What we end up seeing here is we stretch out that circle into an oval and then eventually produce a rectangle or a square, depending upon the diameter and height of the cylinder. And last shape we're going to look at right now is going to be a cone. Cone having that one fixated point similar to a pyramid, but we're talking about a circular base, and we're talking about this circle sense going around, which gives us our cone shape. we take our plane, rotate it, get a semicircle, eventually we point up, and we can actually create just a straight triangle.
So that's pretty much it for today. Just to recap essentially our concepts for this afternoon. We're talking about cross sections, which are going to be essentially our planal swipes or crosscuts through our three-dimensional figures. Just as a reminder, when you're doing that, you're going to have some type of direction associated with it normally, whether that be something which is vertical, like stretching up and down, or if it's going to be something horizontal going across our x-axis, or what we would normally say parallel to the ground going left and right. For today, you'll have in Google Classroom an assortment of questions like an independent practice packet, as well as a handful of homework questions. For our material today, you will not have an exit ticket associated with it. That's going to be saved for Thursday when we actually have some more algebraic type discussions going on, when we begin to refer to the mass inside of our objects as measurements related to volume. As always, if you need any help, please do not hesitate to check out our office hours Monday and Wednesday. I'll be able to kind of go through stuff with you on a more individual level. And then, of course, now on Tuesdays and Thursdays, we're running those live classes as well, too. Just make sure you come prepared watching the Edpuzzle first. Until next time, ciao.